Hello students, in our previous session we discussed about circles under conic sections. Here we shall discuss about parabola in today's session. As we have studied earlier, a conic section, as the name implies, is a section cut off from a circular cone by a plane in various ways. Remember, it need not be necessarily a right circular cone. The shape of the section depends upon the position of the cutting plane. We can see in the figure here the cones generated by the intersecting lines. We consider a double right circular cone of semi-vertical angle alpha and let it be cut by a plane inclined at an angle theta to the axis of the cone. We will get different sections, that is curves, as follows. In case 1, if the plane passes through the vertex O, the curve of intersection is a pair of straight lines passing through the vertex which are real and distinct for theta less than alpha. They are coincident for theta is equal to alpha, that is, the plane touches the cone, and they are imaginary for theta greater than alpha. In the second case, if the plane does not pass through the vertex O, the curve of intersection is called a circle if theta is equal to pi upon 2. It is called a parabola for theta is equal to alpha, that is, if the plane is parallel to the generator PQ. It is called an ellipse for theta greater than alpha and theta is not equal to pi by 2, that is, if the plane cuts both the generating lines PQ and RS. It is called a hyperbola for theta less than alpha, that is, if the plane cuts both the cones. Thus, we may get the section either as a pair of straight lines, a circle, a parabola, an ellipse or a hyperbola depending upon the different positions of the cutting plane. These curves of intersection are called the conic sections. We can view on the monitor here 4 different figures in which we can see a circle is being formed. In the second case you can see an ellipse, in the third one parabola, and fourth one shows hyperbola. Now, let us look into the analytical definition of conic section. A conic section or conic is the locus of a point P which moves in such a way that its distances from a fixed point S always bears a constant ratio to its distance from a fixed line, all being in the same plane. Now, let us look into the definitions of various important terms. What is focus? The fixed point is called the focus of the conic section. Directrix, the fixed straight line is called the directrix of the conic section. In general, every conic has 4 foci. 2 of them are real and the other 2 are imaginary. Due to 2 real foci, every conic section has 2 directrixes corresponding to each real focus. Eccentricity, the constant ratio is called the eccentricity of the conic section and is denoted by E. Axis, the straight line passing through the focus and perpendicular to the directrix is called the axis of the conic section. What is vertex? The points of intersection of the conic section and the axis are called vertices of the conic section. Center, the point which bisects every chord of the conic passing through it is called the center of the conic. What is latus rectum? The latus rectum of a conic is the chord passing through the focus and perpendicular to the axis. We note here that, as mentioned above, the eccentricity of a conic is generally denoted by E, and for E less than 1, the conic obtained is an ellipse. For E is equal to 1, the conic obtained is a parabola. For E greater than 1, the conic is a hyperbola, and for E is equal to 0, the conic is a circle. Look into this figure here. We have got a directrix represented by z, z dash, and we have got a focus represented by point S with coordinates alpha and beta, and there is a fixed point P denoted by h comma k. The Cartesian equation of the conic section, which when simplified can be written in the form a x square plus 2h x y plus by square plus 2gx plus 2fy plus c is equal to 0, which is the general equation of second degree. It can be easily shown that the general equation of second degree, like a x square plus 2h x y plus by square plus 2gx plus 2fy plus c is equal to 0, always represents a pair of straight lines if determinant is equal to ABC plus 2fgh minus af square minus bg square minus ch square is equal to 0, and a circle if determinant is not equal to 0, a is equal to b and h is equal to 0. It always represents a parabola if determinant is not equal to 0 and h square is equal to ab. It represents an ellipse if determinant is not equal to 0 and h square is less than ab. It represents a hyperbola if determinant is not equal to 0 and h square is greater than ab. Also, it represents a rectangular hyperbola if determinant is not equal to 0 and h square is greater than ab and a plus b is equal to 0. So, what is the parabola? A parabola is the locus of a point which moves in a plane such that its distance from a fixed point is in the plane is always equal to its distance from a fixed straight line in the same plane. The fixed point is called the focus and the fixed straight line is called the directrix of the parabola. The line through the focus and perpendicular to the directrix is the axis of the parabola. The point on the axis midway between the focus and the directrix is called the vertex of the parabola. Now, let us look into an example involving parabola. Find the equation of the parabola whose focus is minus 3 comma 2 and the directrix is x plus y is equal to 4. Look into the solution here. Let P x comma y be any point on the parabola whose focus is S minus 3 comma 2 and the directrix x plus y minus 4 is equal to 0. Draw PM perpendicular to x plus y minus 4 is equal to 0, then SP is equal to PM. On squaring both the sides, we get SP square is equal to PM square, which can be written as x plus 3 whole square plus y minus 2 whole square using distance formula, that is equal to absolute value of x plus y minus 4 upon square root of 1 plus 1 whole square. On simplification, we get 2 into x square plus y square plus 6x minus 4y plus 13 is equal to x square plus y square plus 16 plus 2xy minus 8x minus 8y, which on solving gives us x square plus y square minus 2xy plus 20x plus 10 is equal to 0. Thus, the equation of the required parabola is x square plus y square minus 2xy plus 20x plus 10 is equal to 0. Now, let us look into the equation of the parabola in its standard form. Let S be the focus, Z Z dash be the directrix. Draw SK perpendicular from S on the directrix and bisect SK at A. Then AS is equal to AK. Distance of A from the focus is equal to distance of A from the directrix A lies on the parabola. Let SK be equal to 2A, then AS is equal to AK, that is equal to A. Let us choose A as the origin, AS as x axis and AY a line perpendicular to AS as y axis. Then the coordinates of S are a, 0 and the equation of the directrix Z Z dash is x is equal to minus a. Let P x, y be any point on the parabola. Join S and draw PM and PN perpendiculars on the directrix Z Z dash and x axis. Then PM is equal to NK, that is equal to AN plus AK, which can be expressed as x plus A. Since P lies on the parabola, therefore, SP is equal to PM. On squaring both the sides, we have SP square is equal to PM square, which can be simplified as x minus a whole square plus y minus 0 whole square is equal to x plus a whole square, which on simplification gives us y square is equal to 4ax. This is the equation of the parabola in its standard form. Note here that the parabola has two real foci situated on its axis, one of which is the focus S and the other lies at infinity. The corresponding directrix is also at infinity. Now, let us look into the tracing of parabola. Y square is equal to 4ax, where a is greater than 0. The given equation can be written as y is equal to plus or minus 2 into square root of ax. We observe the following. First, symmetry. For every positive value of x, there are two equal and opposite values of y. Region. For every negative value of x, the value of y is imaginary. Therefore, no part of the curve lies to the left of y axis. Origin. The curve passes through the origin and the tangent at the origin is x is equal to 0, that is y axis. Intersection with the axis. The curve meets the coordinate axis only at the origin. Portion occupied. As x tends to infinity, y also tends to infinity. Therefore, the curve extends to infinity to the right of axis of y. With the help of the above facts and by joining some convenient points on the parabola, the general shape of the parabola y square is equal to 4ax. So, students, today we have discussed about parabola and its important definitions with the general equation of parabola. In the coming sessions, we shall solve some problems involving parabola. Thank you.